in case anyone wants to view this later on. You guys are always welcome to go back to it, and they'll be on our YouTube and everything. But yeah, so for this workshop, we'll be getting into like the back end of our application. So if you guys remember, whether you were at that third workshop or not, we kind of covered the front end. We taught you guys like how to use React to build like a user interface. So that was entirely like the front end. That was how it'll look when like you're interacting with it. But we didn't actually build the back end. And if you remember, we kind of filled it with dummy data, just like a bunch of dummy purchases that we hard coded in. So this time we're going to get into like how you can actually create the data yourself and how you can store the data with APIs and databases. Again, I don't really think there's any use for this just because we've been using this to see who's coming, but don't worry too much about this. So just like an agenda for today, we'll first start with HTTP and APIs. Then we'll be creating our own API routes, which we'll use to actually create data for our application. Then we'll get into databases and create our own database for our application. So we're going to basically do the entire backend today. That's the hope. We'll see how far we can get, obviously with time and everything. But we do have our last workshop next Monday. So we'll finish up anything that we haven't finished up this time in there. So I think for understanding the backend, it really helps to start like really, really big with like the internet and then zoom in to where we are with our application. So basically, you can kind of abstract away the idea of the internet to just like a really long wire. That's definitely not how it works, but you can just think about like a really long wire just like looping around the world. Okay. And so that there's a bunch of different computers, right? There's my computer, there's your computer, and all these computers interact with each other by sending data through this wire. Okay. So when we say computers, we generally like to abstract it away into two different kinds of computers, clients and servers. So with clients, clients are generally like web browsers like Chrome, Safari, whatever, like you're accessing on your guys' computers, right? And then servers are any computer that kind of serves or provides data to a client. So if you go to something like facebook.com, there's like a facebook.com server somewhere out there that's actually sending you that data when you click on like your friends' profiles or you like a post or whatever. Like all that data is being saved into databases and servers elsewhere. And the client is actually the maybe it's like the app, maybe it's your phone, maybe it's Chrome, whatever you're accessing it on. So clients generally interact with servers to request data. So again, with my Facebook, like Instagram, whatever you want to think of, like, let's say you click on your friend's profile, you're requesting all of that information. You're requesting their, like how their profile like looks, all the photos that are on their profile, if they have like a bio, like captions, whatever the case might be, right? So we're requesting all of that data, and they do that through this like so-called wire, right? And generally, the way that this communication is done is something called HTTP, which stands for Hypertext Transfer Protocol. It's not really like a language, it's more of like a protocol. So that's why I said language in quotes, but we'll see some examples later on. But yeah, that's basically the protocol or like the standard that computers use to kind of communicate with each other. So clients and servers can both speak this so that they're kind of speaking the same language when it comes to the data that they're requesting. And then later we'll see like responses. So like I said, we have like requests and response. So clients can request for data from a server through an HTTP request. So we can request different types of functionality. And like I just gave the example of getting like your friend's Instagram profile or whatever, right? But there's a bunch of different functionalities, and we accomplish this through request methods. So you can see here that I have get, post, put, and delete. And so get, post, put, and delete are HTTP like request methods that correspond to these four actions. I have it out of order here for some reason, but CRUD, which stands for create, read, update, delete. Maybe you guys have heard of CRUD, like when it comes to like, I know in CSE 110, you generally build like a CRUD app, and this is technically a CRUD app. And a CRUD app is basically an application that does these four actions, right? We can create data, we can read data, we can update it, and then we can delete it, right? So for this application that we're building, it's actually just going to be create and read, just for the sake of like, we have time and everything, but hopefully you guys will learn enough so that if you want to implement update and delete functionality yourself, then you can go ahead and do that. But yeah, so like getting, posting, so getting is generally like reading, so reading some data from the server. Posting is like creating some data or creating it to a database. Put is a little bit like misleading, but it just means like we're updating basically some sort of resource that we already have. And then deleting is like deleting deleting an Instagram post or whatever, right? Deleting a resource. So we send those requests, like the client's going to be sending these request methods for some behavior from the server, and then servers can respond to the clients with HTTP responses. And generally these responses come with status codes to signify the response state. So 200 is generally like, okay. 404, I'm sure a lot of people have seen 404. If you try to like access some resource that doesn't exist, then the server will be like, okay, this, whatever this person is accessing doesn't exist, and they'll send back a 404. 500 means there's like an internal server error. If like you've ever been on a website and it like crashes or anything like that, it's not our fault, it's the server's fault. So you might see some of these codes, and if you click on the link, you can like read all about them. There's quite a few actually. It's not just limited to these two or these three. So yeah. So we've kind of zoomed out and we talked about the internet. We've talked about how clients and servers can like interact with each other, right? But let's zoom into our application, and let's zoom into applications kind of in general. So this is kind of like the standard web application architecture that you're going to see. Our application conforms to this. Like, I think basically you'd be hard pressed to find an example that doesn't conform to this kind of like very general architecture. Obviously, there's a lot of stuff in between, but just to illustrate the purpose of like how our front end is actually going to be interacting with our back end, we have this diagram here. So as you can kind of see here, we have our client, which is basically like our computer, our browser, whatever, right? So like we said, we have HTTP requests and responses. So you can see that my client will interact with my server by sending an HTTP request. My server will take that request and decipher it and be like, okay, this person requested like an Instagram profile, whatever it might be, and it'll send a query to the database, and the database will then find whatever data we've requested and send it back to the server. And then the server will package it up nicely in a format that the front end or the client can understand, and it'll send that back along with like the status code in the form of an HTTP response. And then the client will do whatever it needs to do to like render that data, show it to us in like a format that we can understand. And of course, if there's any issues, we'll have the corresponding status code to kind of decipher what's going on with it. So yeah. So what are APIs? Because we titled this presentation API and then we said API routes. So maybe you guys don't know what APIs are, and that's okay. But APIs are basically the middlemen in this whole operation where we're requesting data and we're sending data, whatever, right? So API stands for Application Programming Interface, and APIs are basically toolkits that a client can interact with. So for example, let's say we're building an app and we want to have like Spotify functionality. So I don't know if anyone knows what I'm referring to, but like every like 8 months, someone creates like a Spotify app thing where you can log in with your username, and then everyone will post it on Instagram, like their top 10 songs for the month or whatever, right? So basically, like let's say we're trying to build something like that where we want Spotify, we want to be able to integrate with Spotify. Maybe we want to just like input the name of an artist, like for whatever reason, we want to just input the name of an artist and get that artist's like top 5 songs or whatever, right? So we can use the Spotify API to integrate Spotify into our application. So it allows our client, our front end, to interact with Spotify servers to get Spotify data. Okay. And I have a couple of examples of this in later slides so we can actually see it in action. But yeah. And then APIs can be like a toolkit of functions. So there can be like functions to do whatever we need to do, or it can also have like API routes, which is what I mentioned earlier. So an API route is a route on a server accessible via HTTP request. So you can kind of think about it like an address almost. So it's like when we send a specified request to an API route, depending on the request specifics and depending on the route, we'll get some sort of behavior from the server, if that makes sense. And then a REST API is basically like a collection of API routes. It's like a standard for how APIs are designed these days. So we're going to be building a REST API today for our own purchase application. So just to like break down an API route, like the syntax of an API route, hopefully everyone's kind of familiar with this layout right here, where it's like the web server, host, and port, and then the API route. So the first part of that, I think everyone's pretty much seen. Like localhost here just refers to just an example of like how we're like if you run a server locally on your computer, it'll be like localhost, but that could very easily say like facebook.com or instagram.com, right? So that means that's like the web server host and like wherever it's being hosted. So facebook.com servers, for example, right? And then the part that comes after that is the actual API route. So /API/purchases means we're like this route exists somewhere on the server. Like, let's just say this is like the local host server, right? So /API/purchases exists somewhere on the server. And we're going to need to, as developers, we're going to need to build in the functionality so that when some client interacts with this, we need to specify some sort of behavior from that, if that makes sense. So for example, if we were to send a GET request to this route, we would expect the behavior to get all the purchases because we've called it purchases, right? If we send a post request with a request body, and we'll get into that later, but basically, let's say sending a post request with like a request body means like, let's say we're creating like an Instagram like post or whatever, right? So maybe that contains like our bio and like all the images and if you tag the location or whatever, right? So a bunch of data that we want stored. So sending a post request with a bunch of that information to this route would presumably create a purchase, if that makes sense. So basically, this is just like a thing that exists on the server. And when we hit this thing, I think terminology that you'll hear often is like hitting an API route. So when we hit this API route with a certain request, we have some sort of behavior. So it's up to us to build these sorts of like GET requests, post requests. Like it's up to us to build the functionality for whatever the request might be. But you can have like an API route that does multiple things. It's just up to you to build different functionality into it. Okay. So I think like to illustrate this, let's take a look at these examples right here. So I just pulled some examples that I think are pretty good. So the first one is kind of like a fun API. It's just called the board API. I think the idea behind this is like, if you build it into your application, you're never supposed to be bored or whatever. So you can kind of see like, there's like a try it out thing right here. And you can kind of see like, this is the first part of our, I think like right up until here, that's the first part of our API route syntax, right? That's basically like the server name. So there's some like board API server somewhere, right? Then we have like our /API/activity. So presumably when we hit submit here and submitting, I guess I forgot to mention this, but hitting submit or like going to facebook.com/posts or whatever it is, whenever you kind of hit return or enter on your web browser, that's like a GET request. We don't have to specify what kind of request it is, but that's just always like a GET request. So when I hit submit here, we're going to be sending a GET request. So I hit submit, and then this is kind of dark, but I guess the activity that you should do now is draft your will. And you can see that there's like a bunch of different things that it comes with, bunch of different information. So you can kind of see that we can also specify additional parameters. These are called parameters. So let's say we want a specific activity with one participant only. You can kind of see like if we send another GET request, I think it updated automatically, but let's just send another one. Oh, look at that. Let's learn a distributed version control system such as Git, and it only requires one participant. So we're basically hitting this API route, this /API/activity, and we're giving it like the parameter of participants 1. So we can easily change this to something like 2 and then send another GET request. And it looks like board API wants us to catch up with a friend over a lunch date. And you can see that this requires 2 participants. So you can kind of see that we're like hitting this route that exists on the server and we're getting some sort of data. So the board API developers developed it in such a way that whenever we hit it, we are basically getting like, I'm sure it's like some random, it just like randomizes some activity to send, and maybe it filters based on the number of participants or whatever. So that's like a fun API, and any API worth its salt will have good documentation. So we can click on the check out the documentation here, and you can kind of see what I'm talking about. It'll kind of list out, it'll be like, okay, this is version 1 of the board API, and it'll kind of list out all the different functionalities that we can do, right? So it looks like for the board API, the only thing that we can really do is send GET requests, which kind of makes sense because we're just getting a bunch of activities, right? And you can like specify a bunch of different things. So like this is the base one, so /API/activity, and this will just return some sort of activity with like a bunch of data right here. Learn Express.js, that's actually what we're doing today. So that's kind of fun. But yeah, you can see like we can specify a bunch of other parameters if we want to find it by key or by type, if it's like recreational or social, whatever it might be. So we're basically just hitting this route, this API activity with various parameters. And based on the parameters, based on whatever we send, this GET request will respond. The server will respond with whatever information that we want. So hopefully that makes sense to everybody. I think I have kind of a more robust example. So board API is just kind of like a fun thing, but I think Spotify is probably something everyone is familiar with. So Spotify actually has like a really nice API. I think they have really, like I said, any API worth its salt has really good documentation. And I think that Spotify has really great documentation. So you can kind of see like Spotify has a web API, and you can see that they actually have on their website like kind of like a diagram of what I'm talking about, right? So let's say you're building an app you can use the Spotify web API to interact with Spotify servers if you want Spotify data in your application. So you can kind of see, like, just scrolling through it. Okay, these are the requests that we talked about. So you can make get, post, put, and delete requests to the Spotify API, just some more information. And the really cool part comes with the reference. Like I said, documentation is really, really key here. So you can kind of see, like, okay, the Spotify web API has a lot of information. You can see that this is a kind of a different API because Spotify, obviously you have Spotify accounts, right? So some data is sensitive. So it looks like to use this API, we're going to need to implement like authorization in some way with OAuth 2.0. But basically, like, you can look through and you can see, like, okay, for albums, and these are called endpoints, by the way, like album, purchases, activity, whatever that last term was, those are called endpoints. So it's like API endpoints exist on the server. So you can kind of think about it like addresses, like on a street or something like that. So you can see, like, okay, we can like get an album. Like, let's just say we build this in where we have like a button, and when we hit that button, it sends a get request to the Spotify API to just get some sort of album. You can see, like, we can specify an ID here to get somewhere in the Spotify system, in the servers, they've assigned an ID to some album. And whenever we specify it, it'll return something here. So you can see, like, with the example, I don't even know what that is, but it looks like whatever album this is referring to has like a release date, a release year, type is album. I guess like it has genres of like, what is that, prog rock? I don't even know what that is. Grunge, whatever. So you can see, like, in the response, we're getting a bunch of metadata, is what it's called, about the album that we've requested. And you can see that this is not limited to just get requests. You can actually, like, if you want your Spotify thing to like interact with your account specifically for whatever reason, maybe you don't like the Spotify UI and you want to build your own, you can actually like save albums for the current user. You can like delete albums if you have any saved to your account. You can do a bunch of things like users specifically, like you can, like, this is pretty much what those applications are doing. Like I said earlier, the Spotify ones that put your top 10 or whatever up, you can see like, it would basically be like get users top items. So whenever you sign into those and you're letting those use your account, it's basically hitting this API route to get your top items. It'll filter by your top songs and it'll put that together in a nice little UI that you can like share on Instagram or whatever. So you can see that APIs are really quite powerful because it's giving you and I, like, this is like free to use. It's giving us like the ability to actually interact with Spotify. Twitter has an API. There's like a ton of APIs out there for a lot of big applications as well. So you can integrate that with your own application. So you can see how these might be really powerful because it allows us to communicate with that server, right? So yeah, that's pretty much why APIs are the middleman. I guess like a good example that I kind of forgot to mention was, I've always heard the restaurant example. So if you kind of think about like the dining area as the front end and the kitchen as the back end and the database, then waiters are the ones running back and forth, right? So waiters are kind of our API in this example because we give waiters our request. They go to the server, which is the kitchen. They make, like, they don't make the food, but they bring it back out for us in a format that we can like appreciate, right? So waiters are the ones running back and forth. So if you're kind of struggling to visualize this, think about it in terms of a restaurant where waiters are the API, we're all the clients, and then the server is like the kitchen, and wherever they store the food is like the back end or whatever, if that hopefully makes sense. So yeah, that's pretty much it for APIs. Any questions so far? Yeah. So the question was like, what would the food represent in the analogy? So I guess the food would be like whatever data, right? So like, let's say we make a get request for like spaghetti, right? We're at an Italian restaurant or whatever. So then we would basically tell the waiter like, okay, my like get request would be like, I want, or like, I guess it would be kind of like not really a post request. So maybe this is like a little bit of a bad example, but let's just say we tell the waiter, like, go get us like lasagna or like spaghetti or whatever, right? The food would represent whatever data like we want, we're trying to get back. So it could be like in the real world example, like if you're on Instagram and you're like like you click on your friend's profile or whatever, right? That's basically getting their profile. So that data, like their images on their profile, their bio, all the followers associated with them, like if they've tagged any like locations in their posts or whatever the case might be, all the information associated with that user is what's being sent back to us, right? We're getting all that information and it's put together in a UI that we can understand, right? So the food would basically just represent whatever data that we want to consume. And it's like packaged together on a plate. We can understand that, and then we eat it like we do. So maybe don't buy too much into the analogy, but yeah, the food would basically just represent whatever data we're requesting back, because they're the ones who take our request, get the food back, and give it to us. That makes sense. Yeah.
Yeah. So you talked about the endpoints. Are those the same as when the data returns? It's kind of like a JavaScript object and it has all the little tags. Are the tags the same as the endpoint?
So that's just the data. Anything contained. So the question was like, when we get like the JavaScript object back. So if you guys didn't notice, we're basically getting JSON data back. That's like a very common format for transferring data. So when we're getting that, that's just it's called metadata. It's all the data that we've requested. So like in the Spotify example, like, I guess like you can kind of see, maybe not this one. But if you like get album, you can see like, are you talking about all this data right here? So this is basically like all the data that we've requested. So like this album has a release date of like December 1981 or whatever, right? So this is just data associated with the album that we can use in our application. The endpoint itself is this /album/ID. That's known as the endpoint. So it's like the address. Think about endpoints, addresses, like the same thing. Yeah. All good? Awesome. Okay. So we've seen like how we can like make these or not. We haven't seen how we can make these, but we've seen how these like work, basically, how we can interact with them. But how do we actually make these endpoints? Let's get into that. So basically, we're going to be using a tool called Express. Maybe some people have heard of it, maybe some haven't. That's okay. But basically, Express is a web application framework for Node.js. Remember, we're all using Node.js here, to start a server locally. So like we were saying, right? We have like servers somewhere that we're sending requests to. So this tool, Express, allows us to start a server on our own computer. So we don't have to like find a server elsewhere, and we don't have to like hit that, right? We can create it on our own computer right here. So it's a little bit confusing, but our client, our front end that we've built, can interact with our server that's also just on our own computer. So we can keep that's typically how you develop projects, because you want to be able to develop it on your computer itself. So yeah, that's basically how what Express allows us to do. And it also allows us to create our own API routes for that server. Okay, so we can create our own functionality that we can hit so any clients can kind of just hit our own server, and we get to decide what functionality we want to provide when people hit our API routes or our endpoints. And Express is cool because it really abstracts away all the complexity of serving a web application. We can do it in literally 3 lines right here, and we've created our own server. This is like requiring Express. We're basically like calling it, we're starting a server here, and then we're saying that the server has to listen on port 5000 on our own computer. And we can literally get that done in just 3 lines here. I don't know exactly because I haven't taken it yet, but I think CSE 124 dives deeper into this sort of stuff, at least in the beginning of the class. But it's a lot more complicated in reality, but Express makes it super easy, and we can just do it in 3 lines, which is why it's a great tool for making our own applications, because we don't have to worry about any complexity. So yeah, let's start getting into our backend here. I think everyone make sure that you have your thing open from last time. I think before we get into it, I will give people, I don't know on Zoom, like if everyone is caught up, but we need to make sure we have Node.js installed. So you can just do that by going to the Node.js website. I think I've linked it somewhere. Maybe Kushi, if you can just send that for anyone who doesn't have it installed, just go ahead and get that installed, because we need that for basically creating our entire backend. But if you were at the last workshop, or you did the last workshop by watching it online, then you should already have it good to go. But basically, it should look like this. I don't know if you guys can see my screen. Can you guys see my VS Code open here? Okay, great. So I'm sharing the entire screen. So yeah, basically, it should look like this, where we basically have our client. We have like a couple other files, like our HTML files from like the first few workshops. Maybe you have additional files, that's okay. But it should basically look something like this. So I'll give people like a minute to like get to this stage if they haven't already. But yeah, let me know if you have any questions, by the way, in the Zoom chat, or just out here. Okay, I'm just gonna move forward, and remember this is all being recorded, so you can always go back if I go too fast or anything like that. But yeah, so basically we should be looking at our code, like this is our code thus far, right? And so if you remember, our client was our entire front end, so we basically like did all this React code to like build our front end. So now we're gonna be creating our back end. So we'll leave client alone, and what we'll actually do is we'll just hit this little button right here to create another directory, create another folder. And you can just call this one server. So server, client and server are typically names that you'll see for like backend and front end. I've also seen backend and front end respectively, but I think server is a good name here. And then what we want to do within this, you can basically like create a new file within it, and let's just call it index.js. So if you guys remember to back into the React thing, we had kind of like in our source, we kind of had like index.js as like the launching point of our application. So it's the same thing with kind of like the back end. In this index.js is going to be like the launching point into our entire application here. So once we create that file, I guess one thing that we want to do is, I guess, make sure that you're at the root level, basically. Then you want to do cd server to jump into our server. So what we're doing is we're changing directory into our server because we're going to install a couple of dependencies that our backend needs. And we've installed our front end. If you guys remember, we installed React Router DOM, which was just a tool that we use for React to be able to like switch to different web pages. But now we want to build that functionality for the backend. So we don't want to install our backend dependencies in our front end folder. So just make sure that you're in the server directory here before we do anything else. So I'll give everyone a minute there. Just give me a thumbs up, I guess, in the room. For Zoom, I guess, just if you have any questions, just drop them in the chat. We have some people monitoring the chat today, but I'll give you guys a second to get there. You guys all good? All good? Good. Good. Are you guys good over there? Yeah. Okay. Great. So now we're in our backend, and what we basically need to do is when we're creating our backend, we need to, it's called like initializing a Node application. So remember that Node is basically like a JavaScript runtime. So what we want to do effectively is we want to create a Node application that will build our backend off of. So type in this line right here, npm init-y, and I will copy it over for the folks in Zoom. And make sure you're typing this in when you're in your server. So you just want to type in npm init-y and hit enter. And that's going to do a bunch of stuff for us. And we're going to see a bunch of, or a couple, just like one file open up here. But basically what that's done is we've initialized our Node application. And so that's what we said, like with npm init. And then the -y is just like a flag that tells us like, yes. So if you just typed in npm init, there would be a bunch of settings that we need to configure. Like we need to configure the name and the version and like the description and the main where we're starting our application from. But the Y just basically defaults all those settings. So we don't have to do all that annoying stuff because we don't really need to get into that right now. But basically it'll do this, and we'll see that a little package.json file appeared. And so if we take a look at our package.json, it basically just contains some more metadata about our application. So the name is server because we're in our server directory. This is like version 1. We haven't really given it a description. We don't really need to, but you guys can. Our main like launching point into our backend is our index.js. There's a couple of scripts. We'll be creating some more scripts that'll make it easier to run our application. And like you can give it yourself like the author if you want to do that. But yeah, that's basically what we've done so far. So we've just created our application, and we've defined some metadata for it. So the next thing that we kind of want to do is install our dependencies. Remember how I said we're going to be using Express? So Express itself is a dependency. It's another framework for Node.js. So what we're going to want to do is say npm install Express, and then I'll type these out, nodemon cores .env, and we're going to see what each one of these does throughout the workshop. So don't worry if you're totally unfamiliar. So just go ahead and like type these 4 in and then hit enter. and let it install, and I'll copy this over for the Zoom folks as well. So let that go ahead and do its thing. I'll give you guys a second to do that, and we'll talk about what has just appeared for us here. Yeah, if you're in person, then you can just check the Discord and the lines will be there as well. But yeah, okay, so what has this done here? We've installed a couple of dependencies. So you can see like, okay, our package.json file, you can see that we now have a dependencies thing. And you can see that it's the 4 that we've installed right here. And package.json basically tells us like what dependencies we have and what version number they are. And this is helpful because I guess I'll explain that a little later. I can illustrate that later. But yeah, so package.json just contains, again, metadata about our application. You can see that we have this node modules folder, which is absolutely disgusting. There's like a million files in here. I don't even know what like all of these do, but node modules is basically the modules for all of our dependencies. So we can't just magically import these and have them work. Some developers out there built them themselves. And node modules is basically all the code that the dependencies themselves need to work. So node modules is really, really big and disgusting. And we actually don't want this. When we push this project to GitHub, we don't want our node modules out there. And the reason why is because of this package.json file. So like I said, this contains all of our dependencies, right? So whenever, let's say like I create my project and then I want one of you guys to like pull it and then run it and maybe work on it. When you run npm install, it'll basically search this package.json file, find all this, the names of the packages, and it'll create its own node modules on your own computer. So we don't want this. So one thing that we can do is within server, just go ahead and create another file. No, not in node modules. So close out node modules, and then just in server, we can just create another file and we can call it .gitignore. And so .gitignore, like the name suggests, basically means when we push this to GitHub, it's going to ignore everything in this file. And so within here, we can just add node modules like so. And we just need to do that and hit save. And then when we push this, node modules folder is not going to go along with the rest of our code. Yeah, Keenan, to answer your question, you would run npm install when like, yeah, pretty much just to make sure that there's any dependencies. So like if I create my project and then you, let's say you didn't do any of this, you could basically pull my code from GitHub and then just run npm install, and it'll install the dependencies that you need locally so that you can do the development on your side. So you always just want to run that when you're pulling code because you want to pull whatever dependencies the project needs. Okay, great. So let's get into some other stuff here. So let's go back to our index.js. And I'm actually going to just give you guys, I think the best way to do this is to just give you the code. And then there's going to be parts where you guys can code yourself, but just for the sake of like following along, I don't want anyone to fall behind. So I'm just going to give you some code here. And let's just dissect it line by line and see what's going on here. So I've just pasted in 3 lines, and I'll do this here as well. So yeah, I've just pasted in 3 lines of code here. Like remember back to the slides, what we said, const express, we're going to just require express. We're going to start a server, and then we're going to have the server listening on something. So server.listen, I'm just doing it on port 8000 arbitrarily because I have other projects running on other ports. You can do whatever number, like generally in the thousands, like 5,000 is common, 4,000 is common. It's just if you have other projects running on other ports. And then remember what this is. Does anyone remember from our JavaScript tutorial, like what this is called when we're doing this inside of a function? It's called a callback function. So we're basically giving a callback function, which is a function within a function, as a parameter. So it'll run this function and it'll basically say, this is an arrow function, if you guys remember, console.log out, server started on port 8000. So I'll give you guys a second to type that out. And then what we want to do basically is when we've done this, just go ahead and hit save. And then you can just type in node index.js. And you can see, okay, server has started on port 8000. Nice. We've started our own server. Yeah, Keenan, the arrow function is the callback function in this case. Yeah, correct. So you can see that we've started our server right here. And the really cool thing that we can do here is if we jump into our browser and we actually type in localhost 8000 or whatever number you specify, you can see this and it says like cannot get slash. You can zoom in here. And I'll explain this in a second. But I'll just let everyone get caught up. I'll jump back over to this in case anyone needs to get caught up here. Everyone good here? Yeah, okay. You have a question? Getting errors? Okay, maybe let's just take a 2 right here. Or can you just check what his errors are? We'll keep going. But yeah, everyone on Zoom, all okay? Just let me know if you have questions. But yeah, so basically we've started our server, right? So if you go to your web browser and you just type in localhost and then the whatever port, it should say cannot get slash. And this is good. This means it's actually working. Remember what I said about how when you enter an API, like an API route into your web browser and you hit enter, that's always like a get request, right? So we're just saying it cannot get slash because we haven't defined our route yet, right? We just started our server and slash basically just means this is just like the default, like a slash here. And it's like the same thing, right? So slash is the default and we cannot get it because we've sent a get request to something that doesn't exist. So now we actually need to build in our get request here. So we'll do that next. So in order to do that, let me think of the best way to do this. So I think I'll just give you guys the code and then we'll walk through it. And then don't worry, so I'll give you guys the get request and then you'll have the chance to build the post request that we're going to build for this. So if I jump over to here and I'm just going to paste this in here. So I'll put it in the Zoom chat for you guys as well if you want to just copy and paste this in and we'll walk through it line by line. Yeah, so basically what we're doing here, and then you guys can also just kind of type this out as we're going along here. But what we're doing here is basically, remember that this line is from earlier, we're just requiring it. We're saying server, we're starting a server. We've introduced this line right here, const router equals express.router. That's basically just creating a router. So if you like hover over it, you can see that it's like type router, okay? And that's just an express thing. So we're creating a router right here. Remember, because we're creating API routes. Then we're basically saying, okay, router.get, and we can say like router.get, router.post, router.put, all of our 4 like verbs that we talked about earlier, right? So we're basically creating a get request or like a get API route so that when our client sends a get request, it'll hit this route right here, and we're calling it /purchases, and then we're giving it another callback function. And this callback function has our request and a response that we're passing into this right here. So remember how I said HTTP requests and responses are things? So we're basically giving our function a request and a response. And we're saying that when this route is hit, when this function fires, we're basically going to return response. We're going to give it a status of 200, which means okay. And we're just going to output some JSON. Just for now, I said like, hi mom, because we don't actually have any data yet. So just to illustrate the purpose, like that this actually works right here, we're just going to go ahead and build this in right here. And then we also have to say server.use /API router. And so if you guys remember to the examples of the board API, remember how it was like boardapi.com/API/activity. So API is just good practice for API design because we want to specify that we're accessing the API route. Okay, so this is basically like the prefix. So this would be like localhost 8000 /API/purchases. And we just want to tell the server to use this right here. And then this is the same line as code as last time. So we basically added in these 3 lines right here. So just go ahead and get that in there. I'll let people in person have a chance to do that. And we can just run it and see what happens. So you'll notice that it's I can like save this, but then this doesn't refresh for me. This is still the same old error message. So we actually have a fix to that we'll get to in a second. But I basically, if you use Control-C, and I think Control-C works for Mac and Windows, you can quit out of this, and then you basically have to type in the same thing again and run it, and make sure that this file is saved before you run it. So we can run it again. We'll see the exact same thing. Server started on port 8000. But now let's jump over here and let's give it our full API route. So we can say API purchases right here. And now we can see that we have hi mom. So basically we're sending a GET request to our API route, which is localhost 8000 /API /purchases. And when we successfully hit our API route, it'll be hi mom coming back to us. Make sense for everyone? In real websites, you don't really see the /APIs. That's something that's removed when companies deploy a website. Yeah, that's a great question. And I think that's pretty much what's going on. When you say /API, it's because we're designing an actual API. So like, when you use the Twitter API, I know the Twitter API is a really good example. We want to specify that we're accessing the Twitter API itself. So when we do /API, we want the API endpoint functionalities. We don't want to be able to like, because do you see how it might be annoying? We're building our own application and we're saying, we can't just say twitter.com/user1, right? That's not the functionality, because when we go to twitter.com/user1, it takes us to the user profile of the user one on Twitter, or however it works. So API is something that you want to specify for when we're specifically building our APIs. You'll see it if you like search up documentation, you'll see that often it'll always say like /API /whatever, and that just specifies that you're accessing the API route itself. I think it probably works implicitly. That's actually a really good question that I need to look into, and I'll get back to you on that. But I suspect that implicitly, like when you do twitter.com/whatever, your client is interacting with the Twitter servers, and it's probably implicitly doing that, because obviously you don't want clients, like everyday people, having to type in API and like not know what it means, right? And it's more verbose and everything like that. So yeah, hopefully that answers your question, but that's actually a good question, and I'll do some more digging into that, and I'll let you know why, because I've definitely seen /API for like real websites as well. So yeah, hopefully everyone can get to this stage where they see hi mom, or whatever JSON you want to get in there. So basically that's achieved because what we're doing is, again, we're creating our GET requests, or we're creating our GET route. And so when we send a GET request by basically just typing in the address to our browser, we're hitting this route right here. We've specified that it's /API /purchases. So then it's firing this callback function. Remember, that's how callbacks work in JavaScript. We're firing this callback function, and we're saying for our response, we just want to send a status of 200, which means okay, like this was a successful GET request. And we're just attaching some JSON to it that says like, hi mom. You can say whatever. We're just saying this for now because we don't actually have data yet. But you can say whatever you want and it'll return that. And we're not using request here because we're not really sending any request specifics. We're just sending a general GET request. We're not sending like any other data with it. So we're not really using the request object. We're just using the response object for now. Does that make sense to everyone? Yeah. Okay, excellent. So I'll give you guys just a second to get this down if you don't already. And then we'll move on. So let's do some housekeeping here, basically. I think part of this is to teach you guys the backend, but part of it is also just to teach you how you would generally structure a backend. So for your own projects, you can kind of get into good like software design. And one thing that we want to do is we want to, like, if we made changes to this, like let's say we build out our post request or our post API route, right? We would have to cancel this. We'd have to Control-C out of this, build out our functionality, and then rerun this. And that's really, really annoying, right? So luckily, one of the imports that we one of the dependencies that we imported was something called NodeMon, which is basically a tool that allows us to just like, it'll always be listening and we just have to hit save and it'll refresh automatically. So what you can do for that is you can jump over to this little, you can jump over to this package.json right here. And you see the scripts, the little scripts thing right here. You can basically add in and I'll copy this for you guys as well, so you guys can just copy this in. You can add in this script called dev. So if you jump over here and then just hit enter and then just copy this in, I may have to retype it. So I'm creating dev, and if it like errors out, just retype it out. Node.mon index.js, and then add a comma afterwards. So this is basically like a bunch of different scripts that we can define. So this is a custom script that we're defining, and scripts are basically what we run down here in our terminal. If you guys remember, we did like node index.js or whatever. So scripts are stuff that we're defining. So we're specifically defining a custom one called node.mon index.js, and we're giving it the name of dev. So if you go ahead and save this right here, and then jump back over here, we can just type in, I have a private Zoom message. I will get to that in 1 second. So I think it's like npm. I think it's run dev. I'm not entirely sure. Might just be dev. Yeah. So it's run dev. And you can see that it's created this like node.mon stuff. And it's like, it gave us a bunch of messages right here. And it's the same exact thing that we had last time, right? Node index.js, server started on port 8000. So if we jump over here and we refresh it, it should be the same exact thing here. But now the cool part is when we jump back to our VS Code and let's say we make a change, and instead of saying hi mom, we want to say hi dad, we can just hit save and it'll automatically refresh at the bottom here. And we can just like go ahead and like send this request again. And this time it says dad. So now we've made it easier on ourselves that when we're like developing our application, we don't have to continually quit out of it and then rerun it. So is everyone good up until this point? You guys all good?
I don't have a script.
You can just add it. If you don't have it, you can just manually add it. Yeah, you can literally just type in like you can just add scripts colon and then curly braces and then just add it in like that. Yeah. Package.json files are it's a very lawless land. You can just do whatever you want in it. But yeah, just go ahead and add it in there. Yeah, everyone on Zoom good? Let me know if you have questions, by the way, just type them out. I will try to get to them. So our code is pretty good up until this point. It's doing what we need to do, but it's still kind of like bad because remember what I said earlier about me saying that this is at 8000. Let's say like you're like Keenan, you were giving the example of like running npm install again. Let's say I'm giving Keenan my code here, but he already has a project that's running on 8000. We want to get rid of this, and maybe if you guys are in CSE 11, I don't know if anyone's like learned the concept of magic numbers yet. But basically, we don't want magic numbers in our code. And basically, magic numbers are just like any random numbers that we don't really give any meaning to. So we want to get these out of our code because it's bad practice for one. For two, if anyone else takes our project, they want to be able to customize it to run on their own computers because they might have different setups, different things running on different ports. So what we basically want to do is within our server, you can just go ahead and hit new file and then title it .env. And if you remember, one of the packages that we imported was .env, like literally the name .env. And that allows us to have things called environment variables, which are basically variables that we can have in this server environment, if that makes sense. Okay, so create a file called .env and then type in this line, port equals 8000 or whatever number you gave it on your computer. Okay, so this is basically saying my port is equal to 8000. And this is what we want to run. We want this to run like this, right? So we have this like this, and again, we're trying to make this more, we're trying to design this more so for other developers to be able to like pick this up and be able to like make changes to our code. So one thing that we want to do is, again, in server, you can just create one called .env.example, and then just type in port equals, and then don't type in anything else. So this example file is what we're actually going to push to Git so that if anyone else wants to collaborate on the project, they can just pull this and then they'll see like this. So then they'll know, okay, so the example was port equals whatever, and then they can create their own .env file and fill it with whatever port number they want to run their project on. So go ahead and do that. And then of course, since we're only pushing this, you can jump over to the .git ignore and then just add .env at the end right there. So it'll ignore this .env file, but it'll push the example. Make sense? Okay, awesome. So there's a couple more like housekeeping things. A lot of these things are just housekeeping things so that we can simplify this project and make it easier to understand the backend structure. So I think one last thing that we need to do is create another folder within server called config. And then within config, let's create index.js. Okay. So you should have basically your structure, your file structure for server should be like, you should just have this config folder within server, and then it should have an index.js within it. And I will give you the code that you need. And then we'll walk through it line by line again. So I gave it to you guys on Zoom there. Kushi, if you can send that to the Discord, thanks. So this is basically the code that we want in our config file here. So if you remember, we imported installed .env, which allows us to have environment variables. And this is basically just, you don't need to really memorize this code. This is just boilerplate code that when you're creating other projects, like when you level up, you basically just put these things in and it makes it a lot easier for you. But you can basically see that for this config object that we're creating, we're just saying like port equals process.env.port. So it's going to look into our env file and be like, okay, 8000, that's our port. And you can see that I also included database URL. This is just for when we do our actual database. So you guys can just leave it in there for now. There won't be any issues because we're not really using it yet. But that's just like, you can see that when we connect to our database, we're going to do the exact same thing because other people might have other databases. Good so far? Any questions? No? Nice. Yeah. So that is pretty much it. And then of course, when we do this, we want to jump back over to server. And then we just want to say something like const config equals require /config. And then we can, so we're basically importing the config functionality so that we don't have to have this 8000 existing in our code anymore. So we can basically say something like config.port, server started on port plus config.port, and then save that. And it looks like I have an undefined config require config. Oh, one unsaved because I didn't save this right here. And now you can see that it started on port 8000. We can give it a little space here so it's clean here. And so now what have we done in the past few things that we did? We've basically just customized our project, or rather generalized our project so that any developer who picks this up can customize it. They basically just need to create a .env file, just create whatever port that they want, and then this will automatically run it. So we're just avoiding magic numbers because that's generally just not good practice to have in our projects. And this makes it a lot cleaner. And we're doing like layers of abstraction because we don't want everything stuffed in one file. Make sense to everyone? Good so far? Zoom, any questions? Just let me know. But yeah, I think we're good on that. So there's still some more housekeeping, and I promise this is the last housekeeping that we're doing. But one last thing that we want to do, like I said, we don't want all of our code smushed into one file, right? Index.js should just be our launching point for our application, but we don't actually want our routes, or rather just this. We don't actually want our route within our index.js. So one last thing that we're going to do is in server, we're just going to create a new folder. Let's call this one API. And then of course, within API, we're just going to create index.js, like so. And then in index.js, I will give you guys the code here. Keenan, I'll come back to the config part. Let me just get this going for these guys, but I'll come back and then I'll kind of explain that once more. But yeah, so go ahead and create that API and then that index.js. And then within that, I'll just get you guys the code here. You basically just want to copy in these lines right here. So the router and then the router.get. So if you come over here, you can just paste these in, and then I need to require Express. We need to require Express again. Anytime we want to use the dependency, we need to require it. So go ahead and just save that, and then you can come here and just get rid of this stuff. We do not need that. And suddenly we have made our code a lot cleaner. This is our entry point into the application. And last thing we need to do, we need to just need to get that imported into our main index.js so we're able to use that functionality. So we will import this as a router. So you guys can just type in const router equals require router. And then if you guys are confused about the requires, we're basically just saying we want it'll search, like, these are directories. / means we're like searching directories. So we have an API directory, we have a config directory, that's what we're searching. And since we only have one file within each, we don't need to specify the file name. It's just going to reach in there and then pull the code out of that file. It looks like I have an error. I think it might be because I didn't export it in here. Let me just double check that. I think, yeah, so you need to just export it, and you'll notice in the config file that the export also exists. So at the end, you can just type in module.exports equals router, go ahead and save that, and now you can see everything is all good. So we're basically exporting this functionality into this file, and then this file is going to pick it up and do all of our stuff. So you can see that we've made our code like really, really clean, right, in this file. And we don't need to have all of our ugly code just like all over the place. This is just good design, and this makes it so it's a lot more readable and we can understand our layers of our code a lot better. All good for everyone? Awesome. So Keenan, you had a question. Does it just take inside the .env and make it usable in other parts of code? Yeah, more or less. So basically the reasoning for this is because other developers, like I currently have a project running on port 5000, and I don't want this project to run on port 5000, right? So let's say that, Keenan, you have something running on port 8000, and my project specifically said port 8000 right here, but obviously that might like not run, it'll like error out, and we don't want that happening, right? So we created a config folder, and this will contain all of our config information right here. And this is basically allowing us to say the port, the specified port that we want, it's going to do process.env.port basically reaches into our env file that we've created, and it'll say, okay, like the port is 8000. So where'd it go? So it'll export this config right here. And then when you go into our server, we're basically saying config.port. So we're accessing the port variable from within our .env file. And that's what's called environment variables. So the .env package that we installed allows us to do that. That makes sense? Hopefully that cleared it up. But yeah, it's good practice because you don't want magic numbers all over the place. You want to abstract away and generalize away as much as you can so that it's a lot more readable for other people. So yeah. All good so far? Okay. Also, can you go to the API folder? Yeah, no worries, no worries. Yeah, in the API folder, you basically want these 3 lines or these 3 things from the main index.js, and you want to export it. So we're creating an API layer, and we'll add our post request here as well. We're creating this layer so that anytime you want to add a router, like an API route, you would just add it right here. So you don't need to be constantly changing like your main entry point to the application. It's just so that we're keeping things a little bit cleaner and a little bit more generalized. Okay. I'll give you guys a second to do that. And then just remember that when you export router down here, really quickly, you just want to import it in your other file like this, so that you can use it right here. Because remember, we're saying server.use whatever. So just make sure you import it. Whenever you export something, if you want to use it somewhere else, make sure you import it. Does that make sense? Okay, I will just quickly make a round here. If you guys are confused about this, actually, this should not be here. Let me take this out right here. This should be the same as the one that was previously in here. That line was like a database thing. We'll get to it. I realize we just didn't get to it yet, but we'll get to it right after we do our post request. So it should just look like this. And it's the exact same functionality. Like if I hit save right here, it'll restart my application, and then I can just refresh this. And I might have timed out or something. Let me check. Oop, we've crashed. Something is wrong. Oh, we want this as like our hi mom or whatever the case might be. Here, so it should just be the same thing as last time. If you save this, that should take care of it. Yep, there we go. Server started on port 8000, refresh it, and we're back to hi mom. So we basically have the exact same functionality, but this time it's a lot cleaner and it makes it a lot easier to add to the code, if that makes sense. All good?
Show how you imported.
Yeah. Just like that. Router equals require whatever. Okay, I'm just going to jump to the next part and then you guys can work on it and then I'll walk around and help you guys out here. And then for Zoom, I'll help you guys out as well. But let's just go back to our slides really quickly. So we've done our Express server locally. We've created our route. Remember where we created this get route here, basically where we're saying we expose a function with our request and our response parameters to use as request and response objects. Quick little notes on this. If you guys remember to our JavaScript workshop, we're putting async here because when we do our fetching our purchases, that's not a real-time activity, right? It takes time to query the database. And we'll get to that later. Don't need to worry about it right now. Just how we're going to design it. So we did our get. We hard-coded like the hi mom. Doesn't really make sense for a purchase, but we just hard-coded it because we haven't actually had anything in our database yet, if that makes sense. So now let's get into doing our post request. So this is like the activity that you guys can do. So we want to send post requests along with JSON data to our server to store update purchases theoretically, right? So you can see that this is kind of the rough structure of how we want this to work. It's the exact same thing with the router.post request response, but there's some more functionality here. And we're basically just like, we wanted to post something, if that makes sense. We wanted to add something to the database. So I recognize we don't have our database yet. So you don't need to worry about like adding to it any databases or anything like that. But I do want you guys to just kind of like work on putting this together, and then bonus points if you can figure out how we can hard code some data that we're going to post. Okay. So yeah, just go ahead and work on that for Zoom folks. Let me see. There's only about 8 of you guys, so I was gonna put you guys in like breakout rooms so you could help each other, but like feel free to like help each other if you need to, but someone will come check on you guys. Just go ahead and define the thing. Yeah, I will give you guys the slides right here, and then I'll help the folks in person here, and then we'll get back to this. But yeah, just go ahead and work on this for now. Let me know if you have any questions. You guys all good? So can you scroll up here? Like, let's see what page it is. So Express is not defined. So that should be in our here. Oh yeah, so we need to import Express. So if we go back, yeah, and just copy that. That should be we just get rid of this. Let's save it. So there's another issue. Server is not fine. Can you go back over the server? Server equals spell. You might just be missing another line. Yeah, you're just missing. Yeah, we will send the code for that really quickly. Make sure you have the use as well, and then the server.listen as well. So make sure it looks like this. We do Ashwin, but it's not up yet. We'll just post the code that we need here, and then after the workshop, we'll paste all. We'll like push all the code that we did in this workshop, so that you guys can like pull it if you guys like fall behind with anything here. But if there's any specific code that you need, just go ahead and like let us know and we'll copy and paste it in for you. Which one? Okay, yeah. So I guess if you guys just need the index stuff, like, okay, so this is the one that should be in the general server directory. This is all the code. And then if you need anything from the API, I'll just copy and paste it in for you. So you can just go ahead and create. So the first one that I sent there is for the general server one, which should just be in the server directory, this one right here. And then the second one is within API specifically. So it's just whatever is there. Did you get your thing fixed?
Yeah.
Okay. So you can get
So now, one more is
so yeah,
this is the thing, right? This is the exact thing. This is now it's that's why we do like okay, yeah.
So we're doing the post request in the API, the index.js in the API. So that's API is going to be all of our API routes there. More or less, yeah. No, because that's specific. So we want to make this. So I think what this code is doing is it would take in a purchase and it's destructuring the purchase and we're getting all the specific like, the name of the purchase and description. But I kind of did pretty quickly. I'll just go over it basically. But it's the same exact structure. We're just doing like router.get, router.post. And we just need to specify some posts. For now, take out the async because we're not defining agents. To use async, we need to define like no, you remember it was a secret kind of yeah. So we're not doing any await stuff here. When we get to the database stuff, yeah. But yeah, you have the right idea. Okay, I'll just kind of go over it because I think most people are a little confused. That might be my fault. But I will get into it here. So we basically want to define our post request right here, right? So I guess this was the activity right here. So if anyone, I'll give you guys actually just 2 more minutes here. To give you guys an idea, but just like it for a hint, because I know some people were confused, you can leverage the request object that we're being passed in, right? Because that's where, if you remember back to our like HTTP requests and responses, the request is where all the data is going to come in for, right? So if you guys can create a route that will return an error message if the purchase doesn't have a name, description, cost, or method. And then if there's no errors, just respond with like the status 200. If that makes sense. I'll just go ahead and do it because I think people are a little bit confused, but I'll explain it. And then again, just let me know if you have any questions and I'll try to explain it the best I can here. But effectively, what we want to do is we do the same exact thing, router.post. We would give it / purchases. And then we would give it our request and our response. We would give it our callback right here, right? So we do this. Okay. And then within this, I guess this is a little bit of JavaScript stuff. So if you missed the JavaScript tutorial, the JavaScript workshop, or you're a little behind on your JavaScript, that's totally okay. But effectively, what we want to do right now is say like, I'll just copy this in actually, and then we'll go over it. And I'll send it to you guys in the Zoom as well, and then we can just take a look at it. So I'm just going to paste in this stuff, and then I'll take out the line that we don't need. So let's break down. I'll put this for you guys in the Zoom. Let's just break this down really quickly, like what we're doing here. So we're defining our post API route, right? We're giving it purchases as well because that, like, we want the client to access like localhost 8000 / API / purchases. But this time when they send a post request to it, we are going to utilize this request. And we didn't previously here because when we get something, we're just asking for something, right? We're not really sending in any data. But when we're posting things, right, we're sending data to be created. So one thing that we're doing right here is we're accessing the request body. So if you remember back here, what I said earlier was request.body, where the body of the request is what we're going to be using to actually pull the data that we're sending. So we're basically doing something called object destructuring, where we're creating a variable called purchase with all the information from the body right here. Then we're basically doing more object destructuring. So this is 2 layers of object destructuring. And this is just a JavaScript thing. If you just want to search up JavaScript object destructuring to understand the syntax, all we're doing is we're saying request.body.purchase. And we're just pulling it into this purchase variable. Then what we're doing is purchases have attributes, right? Remember what we said last time? We'll have like a name, a description, a cost, and a method. And we're basically destructuring each of those into their own variables. So this line is basically searching purchase, and then purchase will have a name, and then the name will get stored in name and description and cost and method. If that, it's hopefully that makes sense to everyone. And then what we're doing is we're just checking to make sure, like, remember in the slides, I basically just said, if it does not have a name, description, cost, or method, like that's an invalid purchase, because this is our logic that we're building in our application, right? So if some user tries to upload a purchase without a name, we don't want that to go through, right? So we're basically saying, like, if any one of these do not exist, we're going to return a status of 400, which is like an error. There's an error, invalid input. Otherwise, we're going to return a status of 200 with everything okay, and we're just going to return the purchase object right there, if that makes sense to everybody. Yeah, so request.body, and I probably just didn't explain this properly, so that's my bad. But request.body, so when we send a request, right, we're sending a post request. We need somewhere to send the data for this purchase. Like, let's say I bought an iPhone, right? I need somewhere to send the name of the iPhone, the cost, the description, and like whether I paid cash or credit or whatever for it, right? So that's going to be sent in the request body right here. So request.body, we're basically destructuring it into this variable called purchase. So if you look back here, it's the exact same thing as saying request.body.purchase. Like, remember the dot operator is like accessing attributes of something, but instead of just saying .purchase, this is like a JavaScript shorthand. So I guess this was like a little bit of JavaScript trivia, but we're basically pulling it into this purchase variable right here. Then we're doing the exact same thing from the purchase variable. The purchase object will have a name, a description, a cost, and a method, right? So it'll pull each of those corresponding ones. It'll like match it up basically. This is the exact same thing as saying name equals purchase.name. description equals purchase.description, right? And we're basically just doing that into name, description, cost, and method. So now we have these 4 variables. And then we're just checking them to see like, okay, if any one of these doesn't exist, this is the OR operator, by the way, if you're unfamiliar, it's like Boolean comparisons. Then if any of these do not exist, and that's what the exclamation mark is, like if it doesn't exist or if it's null, basically, we just want to return a status of 400 with an error, invalid input. Otherwise, if these exist, we'll return like an okay. Remember, this was our 200 okay, and we're returning the JSON version of the purchase here. We're like putting it into JSON format, which is JavaScript object notation, which is the way we transfer data through HTTP requests. Does that make sense? If I save this, we should be good. Yeah, so we're all good there, no errors. Any questions? Okay, excellent. So exactly. Request.body contains the JSON content. So it's in JSON format. Yes, that's why we're doing the dots, right? They're objects. We're just accessing the attributes of our JSON object, of our JavaScript object that we're sending. And yeah, it contains the JSON contents of the new purchase that you want to save into the database. Not exactly the server, but you know, generally you abstract the backend and away into the server and the database. But we want to save that to the database. The server is what's this is all server side right here. So the server is basically handling all this logic, and then when we do our actual database stuff, we'll send it to the database in a format that we can like understand. So does that make sense to everybody? Excellent. So let's see. One thing that we can do, I think that's pretty much it for post request stuff. We can move on to databases because I think we have enough time for that. A couple other like really quick, just like housekeeping things just to make the code work. I'll copy them in for you guys. In the main index.js, you guys need to have these 3 lines right here. I'll copy them in for you guys. So basically, okay, I'll do this systematically. At the top of your code, basically, like right here with when you have like your const express equals whatever in your server, make sure you're in the index.js in the server where you have all these const requires. You're gonna want to type in this additional one right here. Const cores. So cores stands for cross origin reference sharing. And when we create our database, we're basically going to be interacting with our backend, with our server from another resource, which is our database. And so cores is like a security protocol kind of thing that allows us to communicate because there's like security issues with like leaving a server like wide open. We don't want just anyone to connect to it, right? So this is just something that we want for developing it here. And then we also want these 2, I think it's like 3 lines of code right here. So I'll paste this in for you guys, and you guys can just paste this in like right after this stuff. That should do it. Yeah. So we're just using cores again. If you're curious about cores, I highly recommend searching it up and just reading through some of the stuff and watching some YouTube videos. But yeah, cores is just like permission stuff, security stuff. We want this to be in like JSON format, so we're just requiring it to be JSON. And then we want, this is just another specific thing. And again, if you don't understand this, that's totally okay. This is just boilerplate code. Like when you go to the Express documentation and you just like look how to get started with an Express app, it's going to give you all these lines of code. And this is just boilerplate to get started with it. So if you guys are like, what the heck is this? Like, don't worry about it. It's just pretty much how you get started with it. This is just basically saying that this is just like another parameter specific thing that we need to give Express for it to work with our database. So if you save that, that should be all good there. And that should be all we need. Any questions so far? Okay, I'm going to move on just because we have more stuff to get through. But I think this next part is a little bit easier to understand and a lot more like you can visualize it a lot better. I think more people are familiar with this stuff. So we're done with Express. Now it's time for databases. I know everyone's heard the term database, but just to like get some answers from you guys, like what is a database? Like I'm just curious what you guys think a database is. Any volunteers?
Or you can store the information for your server.
Yeah. Yeah. I wouldn't say like store the information for the server, but store the information for our application, right? So it's like, so more generally somewhere to store our information, right? Any like examples of a database? Does that anyone is familiar with? So like the idea of a database, like literally a piece of paper could be a database because it's just somewhere to store my data. We're going to be using a tool called MongoDB, which is like a really cool database that we can use to just get started really easily. And there's not a lot of stuff that you need to understand for it to get working, which is why we're going to be using it. So yeah, a database is an organized collection of data or information. Why do we need a database? We want to store and persist our information between sessions and visits to our website, right? Like we don't want to, like the way that we've been doing with like the little hi mom stuff, like we're just adding it there, but every single time we start that, it's going to recreate that data. And we don't want that. And for other applications that we can build, we can create like really temporary data, but we don't want that. We want to make sure like if you log into Instagram and you post something on Instagram, you don't want that post to go away, right? If you log out of Instagram and then log back in a week later, you still want that post to be there and you want it to be saved so you can access it at any time. So that's why we want to do that. But we also want to make sure that we're organizing our data in a logical way. We can't just throw our data into like Instagram, right? Like it has to be organized in a certain way so that we can access it. Like we were doing the object destructuring with purchases and stuff like that. We want to make sure that we're organizing it properly so that it'll make it easy to add data, remove data, update data, whatever the case it is. In the context of our purchase tracker, this lets us store our purchases and view each purchase that we create. So we don't have to hard code in that data that we did in the last workshop. So yeah, basically the organization of data, there's two main types of databases that you'll see: SQL versus NoSQL databases. So SQL, pronounced SQL, you can also say SQL, stands for structured query language. And SQL databases are known as relational databases, and they basically use tables to store their information. So you'd basically have like, I'm trying to think of a good example. I think you could probably use like an ACM event as a good example. You'd have a table full of students. You'd probably have like, there's like database design stuff that you can get into. Like there's a whole thing with that. But basically you could have like a table full of students and then like a table full of events. And then you can, with a relational database, like the name, the idea, like the name relation, you can form relationships between like the students and the events that they go to, or the students and the things that they do. So it's a way to like link things together. And some examples are like SQLite, MySQL, Postgres. So these are just some examples, but SQL databases tend to have a little bit of overhead in setting up, and they're a little bit more complex to explain. So we're using something that's known as a NoSQL or NoSQL database, which is a non-relational database. So data is stored as documents instead. So when I say document, I mean like, let's say you bought an iPhone and you want to log that into your purchase tracker, right? So you would say like iPhone description, you like whatever, like gold iPhone. I bought it at UTC. It costs like $7.99, and I used like cash to buy it, right? That is one document. That's just like one instance of your data. It's just stored like that. So think of it like you're writing the purchase down on a piece of paper and you're just storing each paper, each document in a stack, basically. That's the way it's working. So some examples are MongoDB. If anyone is familiar with Firebase, that's like Google's, that's basically like a whole backend. So we might have a Firebase workshop later in the year because it's pretty cool, but those are just some examples basically. So in MongoDB, data is stored as collections of documents. So kind of think about it like a folder of documents, and they're basically key value pairs. So to illustrate this, I think this will probably give you guys a better idea. This thing right here, like this singular box, this is a document, and it has a bunch of information as key value pairs. So the same way like JavaScript objects are key value pairs or dictionaries, or like hash maps, if you're familiar with data structures, this is basically the way that it's stored. So like in the context of our thing, this could be like name, iPhone, a description, a gold iPhone 13 or whatever, price or cost, whatever it is, like $7.99. So that's basically the way that we'd store it. And all of these documents would constitute a collection. And we could have multiple collections to form a database. And that's basically the way that we organize NoSQL databases. And this is the way MongoDB works. Any questions? Okay. So let's get into our database setup. I think hopefully we should have enough time to just get through it. So what you can basically do is go to mongodb.com and I'll link this for you guys. Let it load here. Send it in the Zoom chat for you guys. Yes, I want cookies. Sure, why not? So let it load, fire up there, and you guys can just hit like try free. You guys can create an account. This is all free. We don't need to worry too much about it. So you guys can just use like sign up with Google, or like if you want to put in your name, whatever. Like I already have an account, but I'm gonna make a new one just to show you guys like how to go through it. So I'll just use like my ACM email here. So you can just choose an account to get into it, or you can put in your name, your email, whatever, however you want to sign up. Go ahead and accept the terms and just hit submit. And I will pause right here to let people get caught up. Zoom, just let me know if you have any questions. So it should take you to this screen. Let me know once you guys are at this screen, or if you guys are having trouble getting to the screen. So on this screen, we can basically say some stuff like, what is your goal today? Let's build a new application. Or I guess we're learning MongoDB. And this stuff doesn't really matter too much. What kind of application are you building? You can just say other. Doesn't really matter too much, like purchase tracker or something. It's just a personal project. We don't need to worry about it too much. And then what is your preferred language? Let's just say JavaScript for now, and then just go ahead and hit finish. Let it do its thing. And it should take you to this screen. So we're creating a cloud. We're not creating it, but we're going to deploy a cloud database. Databases are like, they're running on servers that are like far, far away. I think there's some in Virginia and there's some in Oregon or whatever. There's like data farms. There's really interesting stuff you can read into if you're curious about all that. But MongoDB is cool because we have this plan, which is like a shared plan, which is totally free. Normally you would need to like pay for like compute space and like server space with all these things. We don't want to pay because, you know, who has the money for that, right? But for now, like that's more like enterprise things, or if you want to host a project that like runs forever or whatever, right? We're just going to go with the shared option right here. So you can just hit like create, and you can see that it's free here. So you can just hit create on this shared one right here. And we're creating a cluster. So you can see like maybe some people have seen some of these names before: AWS, Google Cloud, Azure. So we're just going to use AWS. Doesn't really matter too much. This doesn't matter either. You can just select whatever, just make sure it's in North America. Otherwise you're going to be like doing stuff on servers in like Tokyo or whatever, like no need for that. You can just see like there's some more examples here. You can see like the cluster tier, like this is our free tier, and we have about 512 megabytes of storage, which is all we need for now. You can see that this is just like MongoDB 5.0, and you can actually specify a cluster name if you want. I'm just going to leave it at cluster 0. Doesn't matter too much, but you can create a custom cluster name if you want. So just go ahead and hit create cluster and let it do its thing. I will give a second to let people get through that. And you should be at the screen. There's some security stuff we need to do. Everyone good here in person? Yes, 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 yes. Awesome. Anyone on Zoom? Any questions, any issues? I'll take that as a no. I'll just give you guys like a couple more seconds to get to the stage. Okay, so basically now we need to deal with a couple of security things, because we don't want just anyone accessing our database, right? So we're going to be creating like a database user. This is basically like, you can think about it like just a user, and then your application is going to have the account credentials for this user. So I think convention is pretty much just to go with something like admin, and then for a password, you can just auto-generate a secure password. Just make sure you hit this copy button, because we will need it later to connect to our application. So make sure if you do the auto-generate secure one, just copy it. I'm just going to copy it over. into like a little sticky note that I have over here, just so that you can access it later. So make sure before you hit create user that you copy it and save it, or if you have your own, just make sure you know what it is, because we'll need this to connect to our application. And then you can just hit create user. And now we have this admin, and we use a password to connect. The second security thing that we need to do is IP addresses. So this is also to allow specific IP addresses to access our database. And we've created our first database. Like, look how simple that was just to create our first database right here. So it takes a little bit to get provisioned and set up here. So I'll give you guys like a little bit to get that all set up. Let me know if you have any questions. Hopefully everyone saved that password because you're going to need it. Is everyone here good? You guys need any help? Are you all good? Awesome. Anyone on Zoom need, oh, hold on 1 second. I'll come over. If you hit add your current one, so an IP address is basically like, it's our connection to the internet that we're on. So you want to just hit add my current IP address. So IP address is basically a way of signifying your computer is on the UCSD Wi-Fi network right now at this location. So if you just hit create that one and then just hit finish and close, this IP address is registered. So later today, when you go home to like your dorm or your apartment, wherever you are, it'll be a different IP address because you'll be accessing the internet in a different location. So then you're going to need to whitelist that IP. Whitelisting basically means allowing access for that IP address. So you're going to need to do that. And there's an option later on to whitelist any IP address, meaning anyone anywhere can access it. But that's basically what we mean by whitelist. Okay. Make sense? Yeah. Any other questions? Okay, so it looks like we've got our thing like all set up here, and there's like a bunch of information. We don't need to worry about a good amount of it for now, but you can basically see that we have like we can hit browse collections just to play around with the UI a little bit. Give it a second, it's a little slow. And you can see that we don't really have anything right now. We can add our own data, we can load a sample data set, but we will worry about, we created our post request, so we're gonna rely on our post request to do this job for us, okay? So you can just pretty much go back and see like the main page, and then just click on this connect button, because we're gonna wanna connect it to our app, right? So go ahead and hit connect, and then click on connect to your application. There's some other methods that you can use. I think this is the most straightforward, so just make sure you hit connect to your application right here. Make sure, so the driver is Node.js. Remember, we're using Node.js in our project. And then just go ahead and hit this little document thing, and it'll copy this here. So this is our, if you guys remember earlier in our config file, we had the database URL thing or whatever. This is our database URL. You can see that admin or whatever username you gave it is here. And then you can also see password is here, right? So we're going to need to replace like this part of the thing when you copy and paste it in. And I'll show you where you copy and paste it in. But basically just go ahead and get this copied right here. Then you can jump over to your VS Code. In your .env file, you want to create a variable called db_url. I don't know what happened to my port, but you can create one called db_url and then paste it in. And then what you want to do is go to your password, cut this portion out, and then paste in that password that you had from earlier, right over here. So this is going to allow us to authenticate our connection here. So I don't know why this disappeared. It's weird. 8,000. And then if you hit save, hopefully there's no errors. So if you take a look at our config index.js, you can see that we did the exact same thing. Actually, I think I need to call it DL, like database URL. It needs to be the same thing. So you can see that we created database URL like this. So this is what it's going to need to be called right here, and then just hit save. And so the same exact thing to just explain config files to you once again, we're putting all of our configuration information into this file. And then our config, like our index.js, is basically going to pull this from our .env file. So we're going to pull it and store it into a variable called database URL. And then we can use that database URL to connect to our database. Okay. So in order to accomplish this, we're just going to copy some code in, because that is pretty much software engineering, is just copying code. I'm not lying. So you can see, yeah, don't forget to whitelist your IP. Yeah, so copy the database URL from Atlas. That's what it's called, MongoDB Atlas. That's their cloud database. Store it as a variable in your .env file. This is important. Again, if you guys are confused about like the purpose of the .env file, we don't want to share this URL with the public, because if I post this to GitHub and then some random guy is like, oh, this is a cool project, like let me add on to it, or even if it's not like a guy with good intentions and he just sees this out there and the person is like, okay, I see an exposed database URL, now I can access this, because remember what's in our database URL, our admin and our login and our password, right? So that's the purpose that our .env serves. We don't want other people connecting to our thing. So if we have sensitive data, later on, if you use other APIs, like remember how I said the Spotify API, you need to have something called OAuth, which allows you to authenticate your connection with your Spotify username. We don't want the API key out in the public as well. Otherwise, anyone can just hop on our connection and then have access to a bunch of sensitive data. So that's the purpose of the .env file, and that's the reason we put it in there. Then what we're going to do is we're going to copy these lines of code in here. So let me get that for you guys in the Zoom chat, and then Kushi, if you can get that for the guys in person here. I will copy this in. Oh, and then one thing we need to do before that, my bad, I forgot to do this, is we're going to cancel out of this really quickly. Make sure you're in server. And then we need to basically run this line right here. npm install Mongoose. Mongoose is another npm package that's going to allow us to connect to MongoDB, and it's going to allow us to structure our data. Okay, so just type in this line, npm install Mongoose, and I'll show you guys how to do it here. You basically just type in npm install Mongoose and hit enter. Make sure you're in server. This is a backend dependency, so we want to be in server. Let it do its thing. And then again, you should see it appear in your little package.json. Mongoose has appeared there. So just make sure you type in npm install Mongoose. And it's in the Zoom chat for you guys there. So again, Mongoose is just something that allows us to form a connection with MongoDB, because unfortunately, it's not that easy to just say, oh, I want to use my database and then connect to it. And then you'll see we'll define something called a schema, which allows us to actually connect to our database and structure our data. Okay, let's get this code in here now. So we can just close out of our package.json. Let's go to our server right here, our index.js in server. And then let me get you guys some lines of code. So the first thing that you guys want to do is require Mongoose, right? It's a dependency. So we need to require it. So we can do this. Then the next thing we want to do is set up our connection to it. So go ahead and paste this in right here. We'll walk through it. But you can paste that in like right after the server.use/API. So you can paste it in like right there. So let's walk through this. Let's try to understand what this is doing. So we're saying mongoose.connect config.database URL. This looks a lot like config.port, and it's doing the exact same thing. It's reaching into our .env and it's pulling our database URL so that we don't have to copy and paste it here, because it's really long and ugly and we don't want to have that. And again, if other people have different database URLs, which you do, like all of yours are unique, then we don't want to have like hard-coded values, right? So config.database, and then these are just like dependencies. Again, you don't need to memorize this. I honestly don't know what these two mean. It's just dependencies that you need if you search up the Mongoose documentation, it'll tell you to do this. And if you're really curious, you can look into why it happens, but these are just things that you need, boilerplate code. Then what we're doing is we're using a .then, if you guys remember, back to our JavaScript workshop. This is something that takes time, right? So this is something that could potentially error out. So the .then only fires on a successful connection. And we should console log connected to MongoDB database if all goes well. Okay. And you guys will see if it works really quickly. We'll just save it. And then we should have to rerun our thing right here because we canceled out of it to install. So if you just type in npm run dev once again, npm run dev in our terminal once again and hit enter. Let's cross our fingers. Server started on port 8000, connected to MongoDB database. And if you'll notice back here, we actually wrote this code before server started on port whatever. And so that's just another JavaScript lesson, async and await. This is something that takes time. It takes time to connect to the internet and connect to our database, but this is instantaneous. So this is going to print out first, but then we have a .then. So this is like a promise. So it's like we promise to then once it's connected, print out that we're connected to our MongoDB database. So this should work, hopefully, if everyone has whitelisted their IP. Give you guys a second to get caught up. Let me know if you have any issues getting up until this stage. So whitelisting your IP, it's a security thing, right? We only want your computer, your IP address to access our database, right? So if you remember back in the security settings when we were setting up MongoDB, remember how it said add current IP? That allows us to say, okay, this IP address, meaning like my computer is connected to the internet at this time, at this location right here. We allowed this connection to access our MongoDB database. So whitelisting basically means our MongoDB like security settings know that we need to be connected to the database from this computer. Yes, something was added. I might have forgotten to mention it, but index.json config, make sure you add this line right here. I will paste it for you guys. So database URL is process.env.database URL. So again, the same logic, we're reaching into our .env, we're pulling our database URL, and we're putting it here. And I guess it's good practice to also say, I guess, database URL is whatever. So again, we'll let other developers know, hey, you need to specify a database URL. And again, this is sensitive. This is my password. Please don't hack my database. But yeah, that should be everything you need. And then it should be fine. Server started, connected to MongoDB database. All good? Okay, let's take a quick look. Where's the line? This URL, and you see there. Just scroll up. Not empty servers. One common reason is that you're not trying to access it from the IP that's not. So did you make sure to hit that whitelist your current IP in MongoDB settings? Yeah, so if you go to security, click on database access. Sorry, click on network access, network IP. Who's your current? Go ahead, hit add IP address. And then click allow access from anywhere, just for now. Let it do its thing. It'll take some time, but then restart your application from the VS Code side. And if it's not fixed, we'll get to it a little bit later. I want to get to everything again. Yeah. Okay, let's try to speed through this last part because there's not a whole lot left. We should be able to get everything up and running. But yeah, basically, hopefully you guys were able to get to this stage. If you have any issues, we'll push the code and you can always reach out to us and I'm happy to like help you guys out with them. But just to get through the rest of this stuff, we need to define a schema. Remember how I said databases, one of their purposes was for structuring our data. So we need to define something called a schema. So we need to define what a purchase actually is in our database. So this is like the fun part to me because you get to think about real world things and how they're structured. So like for a purchase, what do we need? We need a name, a description, a location, a date, a cost, and a method, right? And you can see that we've given them specific data types. So the first three should be strings because it makes sense for them to be strings. Date should be a date. Cost should be a number, like if it's $7.99 or 50. And then the method, how we paid for it, like cash, credit, crypto, whatever, should be a string as well. So let's go ahead and it's just a little bit more code that we need to paste in. It's just a lot of boilerplate stuff. So one thing that we need to do is within server, we need to create another folder called models. And then within models, give you guys some code here. Within models, let's create a JavaScript file called purchases.js. Okay. Within here, let me give you guys some code and we'll walk through it once again. And hopefully the idea is hopefully you guys build up more functionality to this application after hack school is over. So maybe you guys can add some more things just after you're seeing how I'm doing it here. So I'm just going to paste this stuff in and we'll walk through it. But I'll give it to you guys in the Zoom chat here. So just go ahead and paste that in right there. And then because you also put that in the Discord for you guys in person here. So what are we doing here? What have we done? Models is basically another way of abstracting away our application. So we're organizing things. And within models, we're creating this schema right here. So schema is a way that we structure data. So you can see all the things I talked about here, right? Name, description, location, date, cost, method, oops. Right here, right? So you can see I created something called purchase schema, new mongoose.schema. So this is why we're using mongoose, right? We need to require mongoose up here. And we're creating a schema. It's just like a method that we can use from mongoose. Name, type string, we want this to be required. Description, type is a string, we want this to be required. Location, date, I didn't really specify required. I specified a default. So like, let's say the user forgot to put in a date, then it'll default to whatever time is right now, whenever they log the purchase, right? Cost, number, we want to make it required. Method, it's a type of string, and then we want to make it required. And we basically just create this. This is just an object, basically. Everything here is an object. And then there's just objects within that. Then what we want to do is use this method called model, because we're creating a model. So we created a schema, which is how our data is structured. And then we're creating a model, which is what we're going to apply to our actual like code so that it follows this schema. So we just use this line, const purchase is equal to mongoose.model. This purchase, this parameter is for the name. So we're just giving it a name of purchase. I can call it whatever I want. Purchase is just most consistent with what we're doing. And then we're using the purchase schema, which is the variable that I created up here, to create our model. Then we're just exporting it here. Make sense? All good? Any questions? Okay, awesome. So now that we have done that, and I'll give you guys a chance to just kind of copy and paste it in and look through it yourselves. There are some more things that we just need to do to make sure that it's all working. We basically need to do our main operations, right? We have our database now. There's no need to hard code data in anymore. So back to our earlier discussion at the beginning about CRUD, create, read, update, delete, known as CRUD operations. These are the main operations you'll be using to interact with our database. Remember, creating data, getting data, updating it, and then deleting it. For this project, we're only going to be doing create and read, but maybe you guys can expand on the project and add update and delete because it's super simple to do that once you see how we do create and read. So for create, we're adding a new document. Remember the way that MongoDB is structured. We're going to add a new document. And again, MongoDB and Mongoose makes this super, super simple. We literally just have these like 5 lines of code right here. So const new purchase equals name, whatever, description, whatever, purchase.create new purchase. So for creation, we're basically creating a new document from our model. So remember that purchase was our model that we created and we exported. And we're basically creating it with another object that we're providing it. So let me give you guys the code for this and we'll just stick it in. So for this part, you guys are going to want to be in the API. Again, just make sure to save things because not saving things breaks it. You guys are going to want to be in the API index.js because this is where we want to do our thing. Then what we want to do is put a couple of things in here. So first thing that we want to do is we want to import our model. We want to be able to use purchase.create. So you're just going to want to copy this line in right here, and then I will give it to you guys in the Zoom right there. So we're basically just reaching into our models folder. So we're using the dot because we have to get out of API, and then we have to go into models, and then we need to go into purchases to get this data for purchase. Okay. Then once we're there, we're going to need to make some changes right here. So you remember how we have async right here? Remember that doing database transactions is not an instantaneous thing. It's going to take some time. Maybe it's like milliseconds and it doesn't seem like a lot of time to us, but it is something that the code cannot execute and we cannot wait for this to happen. We want our other functionalities to keep on running. So we need to preface this with async because we're going to use await, if you guys remember back to our JavaScript workshop. And the line that we're going to use for this, I'll just stick it in right here, is const purchases equals await purchase.find.exec. And this is just a Mongoose method that allows us to find, because this is a GET request. Remember, we're getting all of our data from our database, right? So this just allows us to find, and then exec is just the thing that we slap on top of it. So here, purchase.find.exec. We can also, if you wanted to build another route, maybe this is like a thing that you guys can do to build onto your application. If you wanted to build a route that finds by a specific ID, you could pass in the ID, and this would go in a different route. But basically, that's all you need to paste in here. So let me get that for you guys, and make sure that you're making it async await. Okay, looks like Kushi already got it there. So yeah, now let's do the exact same thing for our posting. So remember, I think I did this out of order, but remember that this is basically what we want to do, right? We simply want to do something.create with our purchase. So if we come back to our code, we want to do this in our post request. And remember, we still want our error handling to happen. We don't want to be able to let the user post something with invalid data, right? So we would do it in our else, and we would basically just post in this line right here. New purchase, await, and remember, if we want to use await, we need to use async right here. New purchase, await, purchase.create with the purchase that we do from here. And then we just need to replace these right here. We're basically outputting this as JSON. Like so. So we're basically bundling this into the format of JSON. So whatever purchases that we're finding from here, we're putting it into JSON format and we're sending that back to the client. In this case, we're creating a purchase, we're bundling it into JSON format, and we're sending it off to the database. Does that make sense? So if you hit save, what was that? Oh, that was a type. It should just be purchases, because we want our whatever we find to be bundled into this, right? So it should just be purchases. Yeah. Any questions about any of that? Here's the one for you. I'll just leave this up so you guys can just copy it in. New purchase equals await, purchase.create, purchase. That's just what you stick in the post request there. And I do believe we have, I know it's 8. So if you have to leave, feel free. But if you guys just want to stick around for like 2 minutes, we'll do some testing and you can see that it appears in your MongoDB database. But yeah. Just give you guys a second to get up to here, get up to this point. So just to show you guys what's going on here. Remember how I told you guys to get this tool called Postman? I will try to keep this out of the way here. So hopefully you guys can see what's like going on here. But remember how I told you guys to get this tool called Postman? Postman basically allows us to send data and like test what we're doing. So basically what I did is I created a post request right here, and I'm connecting to the same exact API route that we defined earlier, correct? And I basically I created a JSON object right here, like a JSON representation of data. I just called it iPhone, 1 terabyte, iPhone 13. I got it at Apple UTC. It was on the 1st of November. It cost what is that, $1,000? And then I used a credit card to pay for it. So I basically created this right here and I hit send. And it basically, if we pop over to our database right here, and we click on browse collections, you can see that I have this thing called purchases right here, and you can see that this is the thing that I just added to it. So I can, like, if you guys don't believe me, I can pop over here and like, what do you want to call this? Like clothes or something, right? I can just go ahead and hit sending request. And if I come over here and I hit refresh, now I have 2 purchases, and one of them is literally the clothes. I guess it's not 1 terabyte, whatever, but one of them is clothes. So we have successfully connected to our database, and now we've given ourselves the ability to send data to our database and have it stored here. Okay. Sound good to everyone? And I guess like, if you guys want to see one last cool trick, if we change this to a GET request, so if we change this to a GET request, and then we just try to send that, we will get the 2 things that we have in our database right here. So we got our iPhone and we got our clothes. Make sense to everyone? Cool. I know this was super confusing. That's pretty much it for this workshop. I know this was super confusing and super quick, and a lot of it was just copying and pasting stuff, but there's a lot of boilerplate. So I think what I'm going to do is I'll probably send out back in 2020, they did Hack School office hours. I don't know how helpful they were, but I'll probably do that for you guys. So if anyone has any questions about what we covered, I'll send out a thing where you can like schedule a time with me, and I can like walk you through this stuff or explain things a little bit better if that would help you guys out. Just so we can like take a more in-depth kind of look at this. And well, of course, we'll review it at our next workshop as well. So hopefully the Zoom folks are doing okay as well. Thank you guys for sticking around. I'll stay here for like a little bit more, and we'll get some questions answered, and we'll make sure that you guys are able to get all the code. So I'll just leave the code up here for you guys here. But that's pretty much it for this workshop. Thanks for coming out. Hopefully you guys learned something. This is like backend stuff. So I think backend is a little bit more confusing than front end. It totally depends on the person, but there's just a lot more stuff, and we tried to get through as much of it as we could. So in the next workshop, we're going to be connecting our front end and back end so that we don't need to use Postman, and we can use our front end to fill out the form. And then when we hit submit, it'll add to our database and it'll show in our view purchases page. So it'll be fully standing on its own legs, and we don't need to use any tools like Postman to test it out and see if it works. Okay, sound good to everyone? Awesome. Great. So in that case, I will see you guys next Monday. That's when our workshop is. We'll send out announcements and stuff, and that one we'll have dinner. So sorry we didn't get dinner for you guys tonight, but yeah, and then that'll be the last one. Your application will be ready to go, and we'll show you guys how to put it on your like LinkedIn, on your GitHub, whatever, on your resume if you want to pimp that out and start sending that out to recruiters and applying to jobs and stuff like that. So yeah, thanks for coming. Hopefully you guys learned something. I will stick around and answer like questions and stuff like that. But I'll stop the recording for now. Yeah, just let me know if you have any questions.
Workshop ever.
Thank you. I'm glad you enjoyed it. Give me just 1 second. Let me pull up my